very near to the AC machine, we can see means if you are using capillary tube, variable continuous flow or constant flow expansion device, this one. Then after the evaporator, before the compressor, here we will be having a device called the same. Which one? Accumulator, AC accumulator. Okay, AC accumulator. How the accumulator will work? The accumulator is just a tank only. If accumulator with the filter dryer option is available. For example, this is your accumulator inlet. Inlet in the bottom, we will be providing a hole. And this is outlet. And also this is outlet. Like a tank, it will come. Then here we can propose some filter dryer and all. Why? To remove, if you are not providing a separate filter dryer, within the accumulator, we can propose it. That will remove it. How the system is working? See, this is from evaporator. From evaporator, still it is liquid plus vapor only. But before going to the compressor, we have to make sure that the phase of the refrigerant is vapor. Otherwise, the compressor might get damaged. Okay, so liquid plus vapor refrigerant will be coming this way. Liquid by gravity, liquid will be coming down and it will be storing on the base of accumulator. Vapor, gas only, it can rise. Vapor will be rising through this way. Then only the vapor will be coming outside. This is going to the compressor. That is going to the compressor. That's the use of accumulator. Correct. Then now we can see little amount of refrigerant. Due to this scenario, we are storing within the accumulator, right? Still it is liquid only. We are storing within the accumulator. So the rate of flow of refrigerant through the loop will be decreasing. Mass is decreasing, right? That's why the amount of refrigerant that is going through the loop will decrease. So the evaporator will be getting enough refrigerant only after some time. Okay. Then what about this liquid refrigerant? After some time, if the room heat is increasing, room heat will increase. Now the refrigerant need or the evaporator need 1 liter per second of flow rate. But little amount of refrigerant is storing within the accumulator only. So as per the demand, the evaporator is not getting the enough quantity of refrigerant. When it is leaving, refrigerant is leaving, it will become superheated, overheated. Because for 3516 watts, we need 1 liter per second of refrigerant. Let's say example. But initially, the room was not that much heat. That's why excess 1 liter per second of refrigerant was coming. When it is leaving the evaporator, it was liquid plus vapor. Now, little amount of vapor we are storing within the accumulator. Let's say, now within the loop, we are not having that much mass of refrigerant, less mass only we are having. So after some time, the evaporator load is increasing, room load is increasing. Now it needs 1 liter per second of refrigerant. But that refrigerant, fully it is some amount of refrigerant is storing within the accumulator only. Due to that, when the refrigerant is leaving the evaporator, it will become overheated, superheated, because it is taking less refrigerant is taking more heat. When it is leaving, the phase will become superheated. So this superheated vapor refrigerant having contact with the liquid within the accumulator. So this liquid refrigerant will be getting sufficient heat. What will happen? The liquid refrigerant within the accumulator will automatically changing the phase into vapor. It is going back to the compressor. Simply, whenever the load within the system is increasing, the liquid refrigerant within the accumulator will be converted into vapor. Then it is going back to the system again. It is not continuously saving within it. When the load is increasing, it will be getting enough heat of vaporization. It is going back to the system. Okay, but the location of accumulator is important. If you are using capillary tube, after the evaporator, before the compressor, we are introducing it, accumulator. But if you are using your metering device or expansion device or throttling device, as a thermostatic expansion valve, it's a mechanical valve only. Or if you are using electronic expansion valve, that's the most common type of valve nowadays, automatic expansion valve. If you are using a thermostatic expansion valve or electronic expansion valve, the rate of flow of refrigerant through the loop this will vary. For example, the AC machine is 1 ton of refrigeration, means 3516 watts. The flow of refrigerant might be 1 liter per second. But evaporator load is 0.5 ton of refrigeration. Let's say 1500 or something, or 1750 watts of heat we having in the evaporator. We need just 0.5 liter per second. Okay. In that scenario, from the condenser, 1 liter per second of refrigerant will come. Until here, there is 1 liter per second only, but this expansion device will be decreasing the flow rate. Until here, that is 1 liter per second, but after the expansion device, if it is thermostatic expansion or electronic expansion, the rate of flow of refrigerant will be decreasing from 1 liter per second to 0.5. Okay. If for 1750, 1 liter per second is coming, then only when it is leaving, it will become liquid and vapor. 1750 watts, if demand is 0.5, only 0.5 is coming, there is no issue, no? We can make sure when it is leaving the evaporator, that will be 100% vapor. Then you don't want to place any accumulator here. You can avoid that. Correct. You can avoid it. That's why if you are using the expansion device, a thermostatic expansion valve or electronic expansion valve, the rate of flow of refrigerant through the evaporator, this machine will be varying. This machine or the expansion device will be varying. So as per the room heat, the demand, that much refrigerant only will be going within the evaporator. In that scenario, we can make sure that when the refrigerant is leaving the evaporator, that will be always vapor. When it is entering into the compressor, there is not a problem. But here it's a problem. Because 1 liter is coming, 0.5 is going. What about the remaining 0.5 liter per second? Remaining 0.5 liter per second, we are storing in this accumulator or receiver. Same function, but location is different. If you are using a variable flow expansion device called a thermostatic expansion valve or electronic expansion valve, after the condenser, before the expansion device, there you have to propose this one. 1 is coming, 0.5 is going. Unwanted 0.5 liter per second of liquid refrigerant we are storing within the receiver, like a buffer storage tank. After some time, whenever the room load is increasing, the metering device will increase the flow. Instead of 0.5, it will be increasing into 0.7 liter per second. Accordingly, the rate of flow of refrigerant through the system will be increasing. That refrigerant from the receiver will be going to the system again. Okay. That's why the function of accumulator or receiver is same only. But receiver or accumulator can act as a filter dryer as well, but that filtration procedure we should do within it. We can provide. So when the liquid refrigerant and the vapor refrigerant is coming inside, the filter dryer will be removing the contaminations and all. Right? We don't want to propose a separate filter dryer. Car AC and all, we are having this separate filter. Okay. So that's why, but accumulator and receiver, the function is same. It will be storing, it will be acting like a buffer tank, and also it will be always making sure the phase of the refrigerant that is leaving the evaporator is vapor, or it is making sure the phase of the refrigerant that is entering into the compressor is vapor, precisely. Okay, but the metering device, if you are using a constant flow capillary tube, then after the evaporator, before the compressor, that is mandatory. But if you are using a thermostatic expansion valve or an electronic expansion valve, automatic type, variable flow, then after the condenser, before the expansion device, you should propose your accumulator or receiver. Okay, but even though most of the manufacturer, along with the compressor, they will be proposing an accumulator for additional safety, but it is not mandatory always. With respect to the type of expansion device, the location of accumulator or receiver will vary. Just understand that. Okay. So this procedure is simply this cooling cycle I have explained. Cooling. Heat pump cycle means the condenser will be acting as a heat absorption device. Evaporator will be acting as a heat rejection device. In normal scenario, compressor, condenser will be ejecting, cooling cycle, condenser will be ejecting the heat to the atmosphere. Evaporator will be absorbing the heat from the room. Heating cycle, that will reverse. In the VRF class, I will explain. Okay. Now you can read these things. Compressor terms. Okay. See, compressor, when we are having two important terms we are having for compressor. Compressor is having a suction pressure. Let's say P1 is the suction pressure. Compressor is having a delivery pressure. Let's say P2 is the delivery pressure. we are having a term called compression ratio. Compression ratio is P2 by P1. For example, P2, if you are having 45 bar, delivery, suction is 15 bar, then 45 by 15, you will be getting 3. That is your compression ratio. Compression ratio value is always higher than unity, higher than 1 only, because compressor delivery pressure is always higher than suction. That's what. Compressor suction. Understood? See, at least 1.7 means normally compression ratio will vary with respect to the type of manufacturer and how much efficiency your compressor is having. Nowadays, like a compressor in inverter technology compressor and all, we are having dual technology, triple technology compressors. Those type of compressors we are having an efficiency, compression ratio higher than 2, 3, sometimes 3.5. Okay. It will vary. It is not constant. Clear? Okay. So anyhow, compression ratio, higher compression ratio means good, like a system, like good thermal efficiency or compressor efficiency or electrical consumption is less. That's a concept. Okay. And what all problems we can expect? What all problems? Normally, most common problem, coil may, in vapor compression system, coil may fouling. Fouling of coil means contaminations will be accumulated on the surface of evaporator and the surface of condenser. So on the surface of evaporator and the condenser coil, the dust particles are accumulating means the effective heat transfer area will be decreasing. That will affect the efficiency of your compressor. Okay. Fouling coil or contaminated coil is an issue. The next one, motor heating. Motor heating. The heart of the vapor compression system is compressor, because this is only moving part. Within the compressor, we are having an electrical motor. When the electrical motor is rotating, by consuming the rotating power, we will be compressing the refrigerant. Okay, we'll be compressing it. See, but if you are oversizing your AC machine, in the basic classes we have discussed, if you are oversizing your AC machine, means your demand is 1 ton of refrigeration or 1.5 ton of refrigeration. You have selected a 2.5 ton machine. Or if you are undersizing your AC machine, means instead of 1.5 ton, you have purchased a 0.75 ton machine. Both the cases, the motor may overheat. Oversizing means room on the peak time. On the peak time, the heat that is generating within the space is much lesser than the AC capacity. AC is taking 2.5 ton, but the heat that is generating is 1.5. So what will happen? Within seconds, AC will start. Within second, it may shut down. If you are using a split AC, inverter AC, the working is different. I will explain. If you are using a conventional split AC, it will start within 1 minute or 2 minutes. Suddenly, it will stop. Again, after some time, it will start. So on-off cycle of your AC machine is too high. If you are undersizing it, on the peak time, heat that is generating within the space is 1.5 ton, but the AC is taking just a 0.75 ton. So remaining heat will be accumulated within the space. You are not going to achieve the temperature set, 24 degrees Celsius or 22 degrees Celsius. What temperature you are setting in your AC machine, you are not going to achieve it. As long as until you are going to achieve the set temperature, your compressor will be continuously working. Both this case, on-off cycle of your compressor is high means your AC motor, whenever it is starting, it will be consuming starting current. That is 2 to 3 times more than, or sometimes 4 times more than your running current only. So excess starting current means your motor will heat. The same way, if you are undersizing it, your compressor motor will be continuously working. So since it is continuously working means your motor, armature winding, everything will become heats up. Your motor may damage. Even if we are having oil, everything inside, motor heating is an issue. Okay. So coil fouling, motor heating, all these are issues only. Anything. Leakage, compressor leakage. Here it is. Compressor leakage means if you are going to this indoor equipment, here only we will be connecting this service. This is called a service valve. Or here only we are connecting the liquid line and vapor line. Sometimes from here the leak can come. The refrigerant will be leaking. Or In any case, your coil, condenser coil or evaporator coil that we are having inside might get damaged due to some reasons and all, or compressor suction side, delivery side and all. Sometimes refrigerant leaking can come. That is also an issue. And one other issue is liquid line restriction. Vapor compression system, we are having suction line. This is your suction line, and this is your liquid line. It's not liquid line after the condenser, your liquid line until this one. Why there is liquid line restriction, not only vapor? See, this is, suppose this is your vapor line, and this is your liquid line. Any problem is happening, means your pipe get damaged. See, the area is slightly damaging. Vapor, it is not a huge issue because vapor is compressible. It will not create that much huge problem for the system because the area of the pipe is decreasing, it will not. But liquid line, liquid is compressible only. So if the liquid line pipe get damaged, so the internal cross-section area of the pipe will decrease. So the compressor has to do more work to overcome the pressure drop that is going to happen for this. That's why liquid line is a problem. Liquid line restriction is a normal problem. These are the most common. Okay, most common things. Anyhow, when you are considering a DX machine, which one? We can study DX machine, but just a curiosity I'm asking. One is bigger one is big one, and other one is smaller in diameter. Different name. This one, we used to call that as suction line, low side line, or low pressure line, or vapor line, different name. This one is called delivery line or discharge line, delivery, discharge line, or high pressure line, or high side line, different names. Okay, so the smaller diameter is liquid only. You can imagine this is vapor. Density of liquid is always higher than vapor only. So liquid need less diameter than vapor. That's why smaller diameter is indoor to outdoor. That is liquid. Outdoor, evaporator to the compressor. This is suction. Okay. That's also like a type of copper, is soft copper only. I will explain that in this one, DX class. Which one? Split AC class. Okay. Now, a few other things. So what are the common component we can expect for a normal air conditioning system? If it's a ductable air conditioning system, what are normal components you can expect? For example, this is a space. Okay. And this is my AC machine. Let's say it's a ducted machine. And it is having, in suction side, it is having some filters with a different MERV, minimum efficiency reporting value. MERV 13, MERV 19 to 20. MERV rating will be varying from 1 to 20. In the filter class, we can study. Normally, AHU, AC machines and air handling unit and all, we are using like a MERV 13 type of filter. Healthcare facility will be using MERV 17 to 20. MERV 19 filters are called HEPA, high efficiency particulate arrestor filter. That is having 99.997% of filtration efficiency. But a filter called 99.999% of filtration efficiency, that is called ULPA filter. The filtration class we can discuss, but the conventional filter that we are using in the residential wall mounted split AC, there is throwaway filter only or washable filter. It is not in a position to isolate bacteria and all. It can isolate only. Okay, in filter we can discuss. I'm not wasting time. Okay, these are filters can come. Then we'll be having a central blower fan. Then we'll be having an air conditioning unit or coil. Then this is your finished floor level and your fall ceiling level. See, we'll be having like supply diffusers on the fall ceiling. At the same time, we'll be having a return diffuser as well. If the machine is located within the space, it is not mandatory to connect your return duct to the return diffuser. This is supply, this is return. But if the machine is located outside, a return duct has to be provided, but it is not mandatory to connect within the space. See, this is your supply duct. Then return duct. Return duct, it is not mandatory to connect. If it is a single space, you can provide like this, because when the machine is working, when it is taking the return through the room, due to the pressure variations, the returner will be going upside. Then through the cooling coil, the temperature will be decreased, or heating coil, it will, if it is a heating, it will be heating. Then we are delivering back supply. This process will be continued. So what all things we need? We need, first one, an air conditioning unit. Means your cooling coil or heating coil. Then you'll be having a circulation fan, because it is not possible to circulate the air, right? You need air terminals. Correct. These are air terminals only. Air terminals. On the false ceiling, we are having air terminals. Then this is your duct. We are having supply air duct, and this is your return air duct. Within the machine, we will be having supply side, return side, we will be having air filters. Okay. Almost all the machine. These are the minimum things we need. Almost all the machine. These things are common. Not only this, still more duct accessories can come. Dampers can come. Then in the supply side and return side, sound attenuators can come. That is different. But these are the important, inevitable things for an air conditioning machine. These things. Still a lot of other items can come. Okay. Now, before going to the AC machine, one more things we should discuss. Type of air conditioning systems. Type of air conditioning system. Before that, this also. See, to give comfort for the people. Factors affecting comfort air conditioning, comfort for the people. What all things we have to take care? Yes. Temperature and humidity we have to take care. We have to maintain, correct. We are dealing with the, not air cooling, we are dealing with the air conditioning. So a lot of things we have to take care. First thing, temperature and humidity. As per ASHRAE, that is for comfort air conditioning, 50% relative humidity, 24 degrees Celsius, dry bulb temperature. That has to be maintained. Okay. Purity of air is important. Indoor air quality has to be maintained. That's why, as per ASHRAE 62.1 standard or 2 standard, we are taking data. People ventilation rate, area ventilation rate, everything we are calculating and we are introducing inside. Motion or velocity of air is important. Why? For example, if this is your finished floor level and this is your false ceiling level, you might be having a supply terminal inside, square diffuser or linear, whatever it may. Finished floor level to 1.8 meter. 1.8 meter. Normally, people will be accommodated within this space only. This space is called occupied zone. Called occupied zone. See, as per ASHRAE, the optimum air velocity within occupied zone is, we used to call that as terminal velocity, T 50 feet per minute. 50 feet per minute or terminal velocity 50 feet per minute. Feet per minute divided by 196.8. We can convert that into meter per second. So this 50 feet per minute is 0.25 meter per second. That's optimum velocity. Otherwise, people will start feeling a discomfort. That discomfort is called a draft. For example, as you know, in the starting classes we have discussed, if you are setting 24 degrees Celsius or 22 degrees Celsius in an AC machine, it doesn't mean that the temperature of air that is coming out from the AC machine in the starting, it is not 24, correct? It might be between 13 to 15 degrees Celsius can come. So this less temperature air, a person is sitting very near to this AC machine. So this cold air with a 13 degree or 14 degree or continuously it is hitting on the skin surface. First 1 or 2 minutes, that is fine. But if it is continuously hitting, means people will start feeling discomfort. That effect is called a draft effect. Okay. That's why when we are designing the air terminal systems and all, we have to make sure that within the occupied zone, the air velocity is within 0.25 meter per second. That's why velocity of air is also important. Sorry, motion of air is also important. Not only that, sound is also important. Means each and every space when we are designing, we have to maintain an NC value, noise criteria value, with a certain decibels. As a thumb rule, most of the spaces will be considering 30 decibel. But ASHRAE, a chapter called sound and vibration. For example, if you are going to 2011 ASHRAE handbook, any sound and vibration handbook, 2011 chapter number 48, there is a chapter called sound and vibration. From that chapter, they have given the NC value. What noise criteria value has to be maintained for a library, classroom, office, conference room. Based on that, we have to design the systems. Because the ductor, when we are designing the duct and all, the flow velocity through the duct system, air velocity through the duct system is too high. It may create some noise. That noise should be less than the limit of NC. So that's why maximum permissible duct velocity we are deciding with respect to the NC ranges only. We'll study in the duct design class. Air terminals design as well. Okay. Sound is also important. Odor, smell is also important. Odor. Okay. Odor is also, because if the air is not perfectly purified, correct, then smell also has to be removed. To remove the smell, filter side, normally bad air if you are getting, means filter side will be providing activated carbon air filters and all. Means we'll be having separated type. Normally that is an integral part of ecology unit. Kitchen exhaust system, we are having this one. Otherwise, this activated carbon air filters are available in the market. This one. Activated carbon air filter can remove odor up to a certain extent. Smell it can remove. So, but these are the four important. Along with that, sound and odor is also important. Okay. So, now, before going to the AC machine, direct expansion machine, classification of air conditioning.
Excuse me, sir. Where we installed this CO2 sensor and this TNRH sensor?
Carbon, that is in exhaust ventilation systems only. For example, like if you're having car park exhaust system. Car park exhaust system. Normally, car park exhaust system will be calculating by 6 air changes per hour. 6 air changes per hour. And with the fire consideration, we'll be considering with the 10 SEH. So fan, we will be selecting with the 2 different speed. Normally the fan will be working for 6 SEH. Otherwise, the fan will be working for 10 SEH. So when we are designing,
but sir, in our project, it was like they installed the sensors in the AHU room, and they have like fetched the data in the BMS. So is it something? It was commercial building. It was a like corporate office building. So is that something to do with the carbon emission and something? That's why they are monitoring this written air.
I will explain. See, to maintain the indoor air quality as per ASHRAE, we are having certain ppm ranges of carbon dioxide. Correct. So when we are designing a DCV called demand control ventilation. Normally, it is not mandatory to work your ventilation machine continuously. Correct. Whenever it is in demand, at that time only it has to work. Correct. So that's why, as I told in the HAP classes, after finishing the machine, again I will be going back to the HAP session. At that time, I will explain this one. Demand control ventilation means whenever it is in demand, at that time only, your ventilation equipment will start. Exhaust fan, how it will work? Normally, the car park exhaust system, the exhaust fan will be off only normally. But whenever within the car park area, we will be having carbon dioxide sensor and we'll be having carbon monoxide sensors. For example, if the maximum permissible range of carbon dioxide is like 3000, with respect to the different standards, it will vary. If it is 3000 parts per million, whenever the carbon dioxide sensors are sensing the carbon dioxide level is higher than 3000 parts per million, then only the fan will start. That is called a demand control ventilation. Whenever it is in demand, that will work. The same way within the rooms. Suppose if you're having a commercial space or a residential space, we have to introduce fresh air. Whenever we need fresh air, at that time only we have to introduce, right? That's why within that space, for your bedroom and all, the limit of carbon dioxide is 400 parts per million. Okay. Whenever the range of carbon dioxide within the spaces is less than 400 parts per million, your AC, air handling unit, if you are using for ventilation, that ventilation equipment will not work. But whenever within the spaces, if the carbon dioxide range is going higher than 400 parts per million, your ventilation equipment will start. Correct. How we are adjusting means multiple spaces, the same central equipment, central air handling unit will be dividing the fresh air with the different spaces. Each and every branches will be having a motorized damper. So this motorized damper will open or close. At the same time, the central air handling unit, fan RPM will be adjusted by the help of a VFD or VSD, everything by the help of this carbon dioxide sensors only. Means by the help of carbon dioxide sensor, we'll be having a centralized control panel. The centralized control panel will be always monitoring the space carbon monoxide or carbon dioxide level. Whenever it is going beyond the limit of parts per million, at that time only the fresh air we have to introduce. Why? So that we can make our machine more energy efficient. Unnecessary, why we are introducing the air within the spaces? Whenever that is in demand, we have to introduce it, right? That's why we are using carbon dioxide sensors, carbon monoxide sensors within the spaces. We are using the sensors not only in car park area, fresh air within the residential spaces. Everywhere you need demand control ventilation everywhere, everywhere we can use this sensor arrangement. But that is conditional. The client is able to accommodate this much amount and all, that is fine. Normally buildings with the BMS systems, we are having this sophisticated, advanced arrangements. Clear?
Okay.
Okay.
Sir, what will happen in case of power failure in that kind of building?
It means your building is having power failure, then you should have an alternative support there. You should have a diesel generator. Correct.
Okay.
Anyhow, if the power is not have necessary work equipments will be functioning there. Otherwise, all your huge big machines are accommodating with the diesel generator. Your capacity of your DG will be too big. So if the building is not having electricity, then at the time of power failure, we are not getting the service. We are managing, we can adjust. But even if power failure condition, if you need the service, definitely you need alternative power source, either UPS or if you have to go for a DG set. Correct. Anyhow, just suppose if you are going to like developed countries, power failure, it will not come. But if it is bigger equipments like AHU or chilled water system, chiller and all, we are not connecting with any diesel generator and all. Those are like a standalone only. Without electricity, it will not work because it is not practically a good idea to provide diesel generators and all for AC equipments because the power that is consuming is too high. So your initial investment will be too bulky. No, client will not be able to accommodate it. Also, to accommodate that much big diesel generator set, multiple numbers you need, not only single, multiple number of diesel generator you need for your building. So you need more space and you need more maintenance cost. You need more running cost. You need more fuel cost if it is DG, diesel generator. You need more initial investment as well. That's it. So if you are not having power, you will not be having this facility in your building. Okay. But if your client is able to accommodate, why? What's the problem in it? If you're having enough money, if you're having enough space, let go for that. No problem. We can design. No. If you are getting something to design, it is too happy. We can design it. We can study something.